All right, guys, this is our first foldable of the second semester, and we're going to jump from chapter 5 to chapter 7. So this is chapter 7, section 1, is what this is over. And in chapter 7, section 1, we're talking all about the angles of polygons. So angles of any shape and the similarities and the differences and how to find the sums and all that kind of stuff. So the first thing we're going to look at is how to find the sum of the interior angles. So remember when we have a polygon, like if we have, I don't know, this polygon here, we have interior angles and exterior angles. So if I extend this here and extend it here, extend it all the way around, this would be an interior angle on the inside. And something like this would be an exterior angle, which is on the outside. Okay, so we're talking about the sum of interior angles. And when I say the sum, that means if we add all interior angles. Okay, so when I say the sum, that means this angle, plus this angle, plus this angle, plus this angle, plus this angle, and plus this angle. Okay, so we're adding them all up. All right, so in order to find the sum of the interior angles of a regular polygon, it does vary depending on what polygon you have. Okay, and there's a formula that we're going to use. So the formula we're going to use is n minus 2 times 180. Okay, n minus 2 times 180. And the n represents the number of sides. I'm going to put in parentheses or angles because how many ever sides it has the same number of angles of a polygon. Okay, so for example, if you have a pentagon, my n would be 5. Okay, if you have a triangle, my n would be 3. If you have an octagon, my n would be 8. Okay, so n represents the number of sides of a polygon. All right, let me erase this real quick, and then we'll look at this example. Okay, so the example says, find the sum of the measures of the interior angles of a convex dodecagon. Okay, so this is the place that if you don't know the name of all your shapes, you need to learn it. And that's something that you could make a list of in your interactive student notebook. Or in chapter 2, we actually pasted one in, and it's on my page 12. So you may want to look at page 12, or you may just want to write it out. If you want me to print you off something that you can put in the interactive student notebook, I can do that too, just let me know. All right, so what you know, or what you should know, and if not, hopefully you know now, that a dodecagon is a 12-sided polygon. Okay, it has 12 sides. And therefore, in this case, our n is going to be 12. Okay, so it says find the sum of the measures of the interior angles of a convex dodecagon. So what I'm going to do is I'm going to do the n minus 2 times 180. That's the formula we use to find the sum of them all, and it does say sum right here. But our n now is 12, so I'm going to substitute 12 in for n, so 12 minus 2 times 180. 12 minus 2, of course, is 10 times 180, and 10 times 180 is 1800 degrees. Okay, so any dodecagon, any 12-sided figure, if I add up all the interior angles, they would sum to 1800. All right, so now let's look at our next flap and under it, which is each interior angle. So when I say the word each, all I'm really talking about is one angle. Okay. Now something that I'm going to talk about at the end about regular polygons, and we're going to write this in our interactive student notebook, is a regular polygon is when all sides and all angles are equal. Like I said, We'll cover that here at the end, but I want you to make sure you know because this does have something to do with it. Okay, so each interior angle, so we want to find the measure of one angle. So what we did before, the n minus 2 times 180, that was the measure of all of them added up. Now we just want to find one of them. Okay, so we also have a formula for this. Okay, so for regular integon, it would be the sum of all. So sum of all interior angles divided by the number of angles, okay? And that should make sense if you think about it. It'd be the total sum divided by the number, because remember, if we're talking about a regular polygon, that means they each have the same measure. So in the example before, when we found the sum was 1800 for any 12-sided polygon, to find the measure of one, we'd just take that 1800, divide it by 12 because there's 12 equal angles, and that would give you the measure of each one. Okay, so let's go a step further here. So the sum of all interior angles is n minus 2 times 180. And then the number of angles that we have is just n. Okay, so this here would be the formula we'd use to find the measure of just one interior angle. All right, let's do an example now. All right, the example says find the measure of each interior angle of a 20gon. Okay, well that makes it easy. Our n here has to be 20. Okay, and we want to find each interior angle, so one interior angle. So we would use this formula down here, the n minus 2 times 180 over n. Okay, now all I'm going to do is I'm going to substitute 20 everywhere I see an n. Okay, so n minus 2 is now going to be 20 minus 2 times 180. Over my n, once again, is 20. Okay, so let's simplify this. That's 18 times 180 divided by 20, which is 3240 divided by 20, which is 162. So each one of the angles is 162 degrees. All right, so now let's look under the flap that says sum of the exterior angles. So remember, the sum means this is when we add together all exterior angles. So we're going to add them all up. Okay, sum of all the exterior angles. Now, exterior angles are easier than interior angles because the exterior, you don't even need to know a formula. Okay, I know it seems weird, but every single polygon, the exterior angle, they always add to 360 degrees. There's no exception to that rule. Every single polygon, if you add up the exterior angles, you're going to equal to 360. All right, so let's look at this example. It says a convex hexagon has exterior angles that measure 32 degrees, 54 degrees, 67 degrees, 100 degrees, and 72. What is the measure of the sixth exterior angle? So it gives us 1, 2, 3, 4, 5. We have to know the sixth. Okay, well, according to this, if we add up all 6, it's going to equal 360. Okay, so let's just make the sixth angle, we'll call it x degrees. Okay, and now let's set up an algebraic equation. So we can say 32 plus 54 plus 67 plus 100 plus 72 plus this sixth angle, which I'm calling x, all these added together has to equal 360. All right, if I put this into my calculator, right, all of these added up is 325. So 325 plus x equals 360. Now we're down to a simple algebra problem, so subtract 325 from both sides. So I get x equals 35. So the sixth one, is 35 degrees. All right, let's look under the final flap, and this is each exterior angle. Okay, so this is the measure of 1. Each means 1. Okay, for a regular entagon. And remember, a regular polygon is one that has all equal angle measures and all equal side lengths. So to find the sum of 1, we would just take the sum of all exterior angles divided by the total number of the angles. Okay, well, let's simplify this. The sum of all exterior angles, as we learned under the last flap, is just 360 degrees, divided by the number of angles, well, that's just our n, and this would be the formula we'd use, okay? All right, so let's look at this over here. It says, what is the measure of each exterior angle of a regular nonagon? Okay, so this regular is important because this regular tells us that all angles are the same, and therefore we can use this. Now, I probably should have come back and highlighted this. This is for a regular entagon. Okay, now for those of you who have forgotten, a nonagon is a 9-sided polygon, and therefore my n is 9. Okay, so to find the measure of each exterior angle, or one exterior angle, I would just take 360 divided by n, but my n is 9, so 360 divided by 9 gives me 40 degrees. So each exterior angle would measure 40 degrees. All right, guys, so that foldable we just did, I want you to glue in the right-hand side on the right page of one of your interactive student notebooks. As we go through this chapter, it just makes more sense. And there are going to be like foldables in pairs. And if you put this on the right side, that would mean those pairs would be on the left and the right as we go forward. But after you glue this down, I want you to also write the definition of a regular polygon. Okay. So a regular polygon is just a polygon in which all sides and all angles are congruent. Basically, all sides have the same length and all angles have the same angle measure.